So students, we have finished the preparation of phenol. So in this video, we're going to see the physical property of phenol. After that, the chemical property of phenol. So in the physical property of phenol, you just have to remember the state and solubility of phenol. So let us see the state and smell of phenol first. Do remember, phenol is a colorless crystalline solid or liquid. In cold climate, it exists in the solid state. In high temperature, it exists in the liquid state, but it is colorless crystalline solid or liquid. Phenol is a colorless crystalline solid or liquid, we say, and they have a characteristic phenolic order. So they have a characteristic phenolic order, we say. So do remember, physical state, it is colorless crystalline solid or liquid, and it has characteristic phenolic smell. If you want, you can take the screenshot of this to make the notes. Phenol are colorless solid or liquid. They have characteristic phenolic order. So this is all about physical state. Now we go to the solubility. You know that alcohol shows intermolecular hydrogen bonding. I have said you in alcohol topic, they show intermolecular hydrogen bonding. So as alcohol shows intermolecular hydrogen bonding, they are fairly soluble in water. Okay, they are highly soluble in water because they show intermolecular hydrogen bonding. That's why they are soluble in water. Whereas phenol is not highly soluble, but phenol is sparingly soluble in water. Not highly, but it is sparingly. Why? Because it also shows hydrogen bonding. You can see here OH benzene ring 1 phenol, OH 1 benzene ring phenol, OH 1 benzene ring phenol, OH 1 benzene ring phenol. And between H and O there is dotted bond. This is called hydrogen bond, dotted bond, hydrogen bond. So it also contains intermolecular hydrogen bonding, just like alcohol. So alcohol is highly soluble in water. Even phenol should be highly soluble in water because of hydrogen bonding, right? But in phenol, this is called aryl group. ARYL, aryl group. Their size is large. Their size is large, and this is non-polar part. Okay, so you can see out here what I've written out. What is written out here? So alcohol is highly soluble in water due to intermolecular hydrogen bonding. So phenol also shows intermolecular hydrogen bonding. You can see from here. So it should be highly soluble, but instead of highly soluble, it's only sparingly soluble, means less soluble in water. Why? Because of non-polar aryl group. This is non-polar aryl group, has very large in size. Okay, so and it almost completely marks the polar character of OH, means this plus minus means polar. So this is going to simply cover the polar character of this, whereby it becomes less soluble in water. So to remember, alcohol is highly soluble in water, whereas phenol is less because of this aryl non-polar aryl group, okay, which is large in size, will cover or marks the OH group, which is polar in nature. That's why it is less soluble in water. Okay, but phenol are highly soluble in alcohol, ether, and also in NaOH, but not in water. So this much you will remember about the physical property of phenol. You can take the screenshot about the state and smell and solubility. And you can remember this hydrogen bonding present in phenol, but due to this aryl group, which has larger size, it will marks the OH, covers the OH, the polar compound group, whereby tendency to dissolve in water becomes less because of this larger size of aryl group. Now students, since we have finished physical property, now we go to the chemical property of phenol. Now students, we go to the chemical property of phenol, which is very important. Chemical property of phenol is very important, students. And whenever we talk about chemical property of phenol, phenol is a very important compound. So it shows three different types of chemical reaction. One is called side chain reaction, the other is called nuclear reaction, the other is called spatial reaction. And all three are very important for phenol. One is called side chain reaction, one is called nuclear reaction, the other is called spatial reaction of phenol. Hardly the compound has spatial reaction, but phenol do have spatial reaction. What is that? We will see later on. So first we will discuss side chain reaction, then nuclear, then physical spatial reaction of phenol. But what is this side chain reaction? What does this nuclear reaction means? That we have to see first. So let us assume this way. Suppose here is phenol. Okay, here is phenol, and you did something whereby this OH group is replaced by chlorine. In the next case, nuclear reaction. Suppose this is again phenol. You did something again out here, whereby Cl group enter here. So students, you can see from here, when phenol is reacted with something, it becomes chlorobenzene. And here when it reacts with something, we get like this compound. So if the top portion gets exchanged, that is called side chain reaction. The functional group is here OH, it has been replaced by chlorine. So if the top portion gets exchanged, we call them as side chain reaction. But here when you do something, chlorine will enter inside the nucleus. Benzene in aromatic compound is referred as nucleus. So when you do something to phenol, chlorine will enter inside the benzene ring. And if something enters inside the benzene ring, that is nucleus, we consider that is called nuclear reaction. So if the top portion gets exchanged, we call side chain reaction. If something enters inside the benzene ring, that is the nucleus, it is called nuclear reaction. And special reaction we'll discuss afterwards separately. So hopefully you understood about side chain and nuclear reaction. So in this video, we will learn about side chain reaction of phenol. Okay, when the top portion gets exchanged, side chain reaction of phenol, and it is very important, even nuclear, even special, but we will discuss side chain first, where the top portion gets exchanged. Now, the first one what we see out here is acidic nature of phenol. Acidic nature of phenol. Do remember student, phenol is acidic in nature. Okay, phenol is acidic in nature. Now let us see why it is acidic in nature. Phenol is acidic in nature. Now let us see why it is acidic in nature first. Students, I'd like to explain you why the question called phenol is acidic in nature. Okay, now let us see out here why phenol is acidic in nature, students. As you know, this is the picture of phenol. Instead of making circle, I am making double bond. And do remember, all the bond contains 2 electrons each. And this oxygen also contains 2 lone pair of electron always, and it is linked with hydrogen along with the benzene ring. So this lone pair of electron which is present in oxygen, okay, it takes part in resonance, which we have learned in class 11. So this lone pair of electron will come here, this lone pair of electron will go here like this. This phenomena is called resonance, cyclic process it is. It moves like this, students. And this process is called resonance. So the lone pair of electron present in oxygen atom of OH group takes part in resonance, whereby here the electron density becomes less, means the population of electron becomes less, whereby this OH bond becomes weak. Therefore, it can be broken down easily to produce H plus ion. And you know that those who produce H plus ions are called acid. That's why phenol is acidic in nature, we say. I repeat again, in phenol, I am giving you the answer, pay attention. In phenol, answer has been already given to you, I am just explaining once again. In phenol, oxygen atom of dash OH group, oxygen atom of dash OH group contain 2 lone pairs of electrons, which takes part in resonance, due to which the electron density on oxygen atom becomes less. Density means population of electron becomes less, and the O-OH bond becomes weak. Therefore, it can be broken down easily to produce H plus ion. And since it produces H plus ion, that is the reason why we call it acidic in nature, and that is the reason why its another name is carbolic acid, students. Hope so you all understood this explanation. Now, if I ask you one question, name one aromatic acid which does not contain COH group. Name one aromatic acid which does not contain COH group. You can say phenol, because in phenol there is no COH group, but yet it is an acid. So I repeat again, name one aromatic compound which is an acid but does not contain carboxylic acid group, that is COH group. So the answer is phenol. Students, hope so you understood why phenol is acidic in nature, because phenyl group present shows minus I effect. I repeat again, I'll show you once again here. This is your benzene ring, and here is OH in phenol, and here will be the 2 lone pair with the oxygen. In phenol, benzene ring with dash this much, benzene ring with dash this much is called phenyl group, PHENOL, phenyl group, and it shows minus I effect. We have learned in class 11, minus I effect means minus inductive effect. Minus inductive effect means electron withdrawing effect. So this phenyl group shows electron withdrawing effect and withdraws the electron of oxygen towards itself. So as it withdraws the electron of oxygen towards itself, the electron density on this oxygen becomes less, whereby this OH bond becomes weak. And as this bond becomes weak, it can be broken down easily to produce H plus ion. So as the electron density becomes less, this OH bond becomes weak and can be broken down easily. So as it breaks down easily, what we get here is minus plus H plus. So Phenyl group shows minus I effect, withdraws the electron of oxygen towards itself, whereby the OH bond becomes weak and it can be broken down easily to produce H plus ion. And you know that those who produce H plus ion are called acid. Those who produce H plus ions are called acid. That's why phenol is acidic in nature. So since phenol is acidic in nature, students, that's why its another name is carbolic acid. Do remember. That's why its another name is carbolic acid. So why phenol is called carbolic acid? If this question comes, you have to say that phenol is referred as carbolic acid. Phenol is referred as carbolic acid because it is acidic in nature, because it is associated to produce H plus ion. And it is one of the acid which does not contain COOH group. Most of the acid contains COOH group, but it does not contain COOH group. Yes, it does not contain COOH group, but yet it is an acid. So another name of phenol is carbolic acid. Do remember for MCQ question. Now we came to know that phenol is acidic in nature. That means if it behaves like an acid, it can react with metal. And you know, in class 10 you have learned, whenever acid, I'm not saying it as an alcohol, I'm saying it as an acid. Whenever acid reacts with metal, hydrogen gas is liberated. Whenever acid reacts with metal, hydrogen gas is liberated. Now to balance it, right here 2. So this 2H is here, students. Now what remains here is 2 benzene ring with O is left. 2 benzene ring with O is left, and to fulfill the place of this H, from here sodium will come. And here sodium becomes 2, so put here 2 to balance. And this compound is called sodium phenooxide, which is a salt. So the salt of phenol is sodium phenooxide. Salt of phenol is sodium phenooxide. And this reaction proves that phenol is acid in nature because it reacts with metal to liberate hydrogen gas, which has a pop sound. Similarly, phenol is an acid. Just now I said phenol shows acidic nature, so it can react with base. And you know, in class 10 you have learned, whenever acid and base reacts, we get salt and water. Such reaction is known as neutralization reaction. So here, being acid, reacts with base, so we get salt and water. So this OH will go with this H and forms water. OH and H forms water. Now let us see which is the salt we get again out here. So this OH and H went to form water. So here what is left? ONA. So ONA will enter here, and the compound name is sodium phenooxide, which is a salt. So acid base gives salt and water. So this reaction proves that phenol is acidic in nature, students. Now students, we go with another property, side chain reaction of phenol. And you can see from here, top portion has been exchanged, so it's side chain reaction. Top portion has been exchanged, so it's side chain reaction. If something enter inside the benzene ring, that is called nuclear reaction. But right now we are doing side chain reaction, so top portion only will get exchange. Now next is the reaction with PCl5. And we have already learned the job of PCl5 is to remove OH and to introduce Cl. Do remember, the job of PCl5 is to remove OH and to introduce Cl. So what we do out here, we can break this PCl5, that is phosphorus pentachloride, like this. So when you break this H will go with this Cl to form HCl. And this O goes with PCl3 to form POCl3. And the name of this compound is phosphorus oxychloride. So H went with Cl, PCl3 went with O to form phosphorus oxychloride. Now nothing is left in benzene ring. Okay, now from here what is left? Chlorine will come up to form chlorobenzene. If you remember, in the preparation portion, we prepare chlorobenzene to phenol by Dawes process. We started with chlorobenzene and we prepare phenol by Dawes process, but it is opposite of that. So when you put PCl5 to phenol, it converts to chlorobenzene. Now you are going to remember this as an objective question. When phenol reacts with phosphorus pentachloride, the compound form is 4 option. You will take it in chlorobenzene. Also you all understood, which is very important reaction. Now we go to the number 3, which is also very important, student. Reaction with zinc dust. So now this is your phenol reacting with zinc dust. Distill means to heat till it vaporizes. So when you react phenol with zinc dust and distill, this is a very important reaction. See what happens. Zinc is a reducing agent. I have said you in metallurgy. Zinc is a reducing agent. I have said you in metallurgy. So being reducing agent, it removes oxygen from here and forms zinc oxide. It removes oxygen from here and forms zinc oxide. And this H will drop down here, because here is CH, here is CH, 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 but here is only C. But as this H drops down, it also becomes CH. And what we get out here is benzene. What we get out here is, students, benzene. So this is how we convert phenol to benzene. This is how we convert phenol to benzene. So when you add zinc dust to phenol and distill, what you get? You get benzene, students. And it is also very important reaction. Now we go to number 4, side chain reaction of phenol. Now here phenol I am reacting with ammonia using catalyst like anhydrous zinc chloride and heating at 300 degrees Celsius. Okay, so when you react phenol with ammonia, using catalyst like anhydrous zinc chloride at 300 degrees Celsius, you see what happens. This OH from phenol will go with one of the H from here and forms water. Eliminated. OH from here goes with one of the H from here to form water. Now what is left here? If one H goes with OH to form water, here NH2 is left, NH2 is left, that will enter here. NH2 is left, that will enter here. And this compound is known by the name aniline. A-N-I-L-I-N-E, aniline. So the question may come here, convert phenol to aniline. This is the answer. Or the question may say, the product formed when phenol reacts with ammonia using anhydrous zinc chloride as catalyst at 300 degrees Celsius. So the answer is aniline. So we have finished 4 side chain reactions so far, students. All are very, very important. Now we go with the 5th side chain reaction, which is the last one. Okay, let us see this. Now phenol is reacting with acid chloride and phenol is reacting with acid anhydride. Now this is your phenol, you know that. This is your phenol. Okay. Now reacting with acid chloride. Acid chloride is a general name. Acid chloride is a general name. And the particular formula of acid chloride is CH3COCl. And this compound is known by the name acetyl chloride. This compound is known by the name acetyl chloride, CH3COCl. And these two react in presence of catalysts like pyridine. Okay, catalyst is pyridine. So when you react these two compounds, students, see what happens here. This H of phenol will take the Cl from acetyl chloride and forms HCl. H and Cl, HCl out. Now here what is left? Benzene ring with O is left. Benzene ring with O is left. And from here what will come? COCH3 here. So benzene ring with O is left out here. From here COCH3 will come. And when phenol reacts with acetyl chloride, that is general name acid chloride, in presence of pyridine, you get this compound. And this compound is known by the name phenyl acetate. CH3COO. CH3COO is called acetate, and here is phenyl, so we call phenyl acetate. So when phenol reacts with acetyl chloride, you get phenyl acetate. So these two compound may be given in the reaction in presence of pyridine. What you get? 4 option, you take it in phenyl acetate. This is the Rothbach. Now the next one. Now again you are reacting phenol with acid chloride. Acid chloride is the general name. Acid chloride is the general name. Acid chloride is the general name. The particular name is acetic anhydride. Acetic anhydride. Acid anhydride is the general name. Particular name acetic anhydride. Formula CH3CH3COCOO. Formula of acetic anhydride is CH3CH3COCOO. Now this is reacting with phenol in acidic medium. H plus means acidic medium. So we are reacting phenol with acetic anhydride in acidic medium. This is another reaction. So when you react these two, students, this H of phenol again will take this much portion out. Whereby what you get? CH3COOH. What you get? CH3 is here, then COOH. CH3COOH is out. CH3COOH is out. That is acetic acid is out. Now here remains benzene ring with O. And here remains COCH3 that I have attached here. Benzene ring with O with COCH3. And this compound is same. So what you get again is phenyl acetate. So do remember, students, whenever phenol reacts with either acid chloride, particular name acetyl chloride, and with acid anhydride, particular name acetic anhydride, in both the cases you get the same product, and that is phenyl acetate. You get the same product, phenyl acetate, but the catalyst used for this is pyridine, for this is acidic medium. So these are the 5 main side chain reaction of phenol which you have to study and learn it by heart. Learn it by heart. I guarantee you. Okay, from here this reaction is very important. Reaction with zinc, reaction with ammonia, reaction with PCl5, and this acidic nature. One question you may get in your board exam. So by this we come to the end of the chemical property of phenol, in which we finish side chain reaction. And in this reaction what you saw, only the top portion got exchanged. Now in my next video we'll go with part B, chemical property of phenol, part B, nuclear reaction, where we see, okay, something will enter inside the benzene ring, and that is called nuclear reaction. So in my next